Hello. We're going to focus on age structure diagrams today. So let's get into this. Now these structure diagrams, they look like this here, and they're used to help us analyze a population and predict how that population is going to change in the next 50 years, 100 years, so and so. And it kind of allows us to understand, all right, do we need to prepare for something? Do we have a lot of population coming in, little, and so and so? So when we're looking at one of these graphs here, there's some things you want to notice. First, we are split by male versus female. So one side is going to show female, one side is going to show male. Then you're going to see these colored bars. Each of these bars represents roughly a 5-year age difference. So we have 0 to 4, 5 to 9, 10 to 14. So this one's 4 years, sometimes they're 5 years. And then below, we're either going to see population in millions or we're going to see the percentage of a population. So collectively, that's what creates these age structure diagrams. I'm sure you've seen them before, but now let's just give a little bit more context to what's going on here. So I think I already talked about all this already. Our y-axis is age, generally shown in 5-year increments. X-axis is proportion. It's also percent, and then females are normally on the right, males normally on the left. All right, so now let's look at how we can use this whole thing to analyze something and get a perspective. First thing you're going to notice is that we have separated these different groups here. So this first group down below, this is the pre-reproductive age. They've yet to hit reproduction. Then in here, we have the reproductive age. Normally that age is driven by females who are able to reproduce. And then above that, we have our non-reproductive. So more of our elderly population that's above there. Now looking at this graph here, we can see that we've got a large amount in the working/reproductive ages. So this could be a good sign. We have some of these bars here in these larger bars in the 20, 30, 35, 40 area that signify that, great, we're going to increase the reproduction. But down below, unfortunately, shows we have very few that is 0 to 15. So it could be an issue if this is replacing our current years of reproductive growth, we may see a downtrend there. And finally, this top area here normally shows kind of what are the environmental factors? What are the economic factors? Do we have a great health system? Do we have a lot of technology in that system that we can prolong life? Is our nutrition good? So this top half kind of helps us understand some of the economic factors and environmental factors that would lead to an increased population in our elderly ages or longer lifespans. These structure diagrams are used to predict our future population growth. We're generally going to consider women's reproductive years about 15 to 44. That may be beyond, what is known in some countries, but technically the women can reproduce between those ages for the most part. If we see a large percent of population in that pre-reproductive stage or below 15, then our population is expected to grow. So that's a big thing that we're going to be looking at. However, if that is smaller than the older population, then our population is expected to shrink in the coming years. Okay, so this is Ethiopia. This looks like, you can see it's a beautiful curve here that we have going on. And you can see clearly our younger years, we have a much greater population, and it just slowly decrease all the way towards the top. Incredible. If we sum up the people under 15, we find that 42% of the population right now is pre-reproductive. So as they get older, they're going to continue to reproduce. They're going to have a lot more children, and just causing these bars to get larger and larger and larger. Now, we notice that there's only about 4% of the population right now in between that 40 to 45 year range. They're about to leave the reproductive years, but they're going to be replaced by 13%. So you can see they're being replaced by a larger amount of the population, and that's going to cause that increase in growth rate. Now this tree, this is a stable population. You see the big difference is that it's very flat-sided. So different side, we have 42% of the population's in its reproductive years. 21% of the population is pre-reproductive. So if we take apart this, so we can see that 7% of the population is about to leave those reproductive years. But then 7% is going to enter them. So we have 7% going, 7% coming in. So there's not going to be a massive change in our growth rate for this population. It will maintain its size. All right, now this is Japan. It's also very much symbolic of Korea. In addition, the first thing I see is I'm like, whoa, what is going on here? But if you notice, they've grouped that elderly group into 75 plus and older. So that could be upwards of 25, even maybe 30 years worth of the population. So that is why that is so much larger. It also indicates that we have a good economic and a good nutrients, and we have good health care that is prolonging the lives of our elderly. Now, currently in our reproductive years, we have each one of these bars is representing about 7% of the population. However, our pre-reproductive is smaller. It's closer to 5%. So when one of these 7% leaves the pre-reproductive years, we're going to bring in a 5%. That's not good. That means that our population is actually shrinking and is getting smaller and smaller. Again, this is an issue in Japan and an issue in Korea because our bottom population is much smaller than the top group of the population. The last thing I'm going to notice here is this bar for women is much larger than it is for men. That is just in general, women have a greater likelihood of outliving their partners than men do. All right, now circle this one. This is what you need to memorize. This shape here showing rapid growth, high fertility, lots of babies being born here. This is slow growth, so United States, kind of Australia generally. This shows zero growth because our flat on the side. So that means we're being replaced by the same percentage. So there's not a lot of growth that's happening. And then we have negative growth. This is a brand new phenomenon that we have not had in the last 50 years or so, where we have this negative growth. And Sweden's seeing this, Germany's seeing it, Korea's seeing it, Japan's seeing it, where we're much smaller in the bottom than we are at the top. Okay, so this is how we go from these age structure diagrams to a graph. We see here we pretty much have an exponential growth in our population. I didn't mention this before, but when you see this large amount of 0 to 5 years, it means that they're having a lot of babies, high fertility rate, but many may not be actually succeeding and living through those first 5 years. But over time, we're going to see an increase, so this population is going to grow exponentially. As the sides of our age structure become parallel, this means we're going to have no increase. And so this graph here shows that we're not going to have an increase as our time passes. And then finally, if the bottom age of the structure is narrower, that means that we're going to have a decrease. So our rate of growth is going to slow and it may eventually decrease. So our graph would look something like this. All right, I really like this diagram here. This is showing India's population and how it's changing from what it used to be. You can see we're going from having that pyramid shape to having much more straight-sided. So that means the population is becoming more stable over time. This could mean things such as This could mean things such as we're improving our economic factors, we're increasing our health care, it's better, so more infants are surviving to that next stage, and our nutrients are better over time. So an interesting change you see going on. And this is a great video about Rwanda's population. If you're interested at all, I think I'd highly recommend it. All right, thanks guys.